Hello guys, this is Investigation 3.3. In this investigation, it is called Connecting Growth Rate and Growth Factor. So in this investigation, you're going to be conceptualizing how will the growth rate and the growth factor kind of work together and put this into a more real-life context. And we'll be talking about a lot of money because this is where money really comes into play. So our focus question, how does the initial population, that initial value, that y-intercept, whatever you start out with, affect the growth patterns in an exponential function? And I'm sure that's already, you're mulling it over in your brain. If we have a smaller initial value, what do you believe its outcome is going to be in comparison to what if we have a larger initial value? What could the outcome be? So let's think about that. Let's play around with it. First of all, I'd like you to add this to your words worth knowing, compound growth. So add that to your words worth knowing. Compound growth is essentially this concept. So say we had that stamp from Sam's stamp collection that we were talking about, Sam's stamp, and Sam's stamp had a value of $2,500 to begin with. After that, we were saying that it had a 6% growth rate, so that after 1 year, we were saying that that stamp was valued at $2,650, so $2,650. In the second year, it still had that 6% growth rate, so we are not just doing that 6% off of our initial value, we are multiplying this 2650 by that 6% and adding 2650 to it. So our growth is compounded through the previous transaction. So we end up getting something like 2809 as our value for that second year for that stamp. So because it relies on the year prior's value, this is what is called compound growth. So I would suggest pausing the video and writing this down and understanding really what compound growth is. Something that relies on the growth prior to, and that's what all of our stuff is that we've been talking about. We've been talking about this growth that continually happens, and we've been talking about the growth factor that is relying on the previous value. And that whole concept of that growth is called compound growth. So pause the video, get this down. I'm going to move on. So if you don't pause, you're going to lose it. See ya. All right, here we go. How does the initial value affect growth? Let's look at this particular question. We have John, he has $100, and we have Cassie, she has $150. They both put their money into a savings account which accrues 6% interest each year. Who has more money at the end of the first year? 5 years and 10 years. So let's first of all figure out the equation for John and figure out the equation for Cassie, and let's look at our growth rate versus the growth factor. Our growth rate is 6%, and we know that if we were to take $100 and times it by 6% or 0.6, because these are equivalent, we'd end up with just 6. That's not how many dollars John has in his bank account after a year. He doesn't go from $100 down to 6 unless he spent money. But this is a savings account, so he shouldn't be spending money out of it. So the way we can account for that $100 that he initially puts in there is saying that our growth factor for this situation is going to be 1.06. Hopefully that ties into our previous investigation. So our total amount that he has is $106 in that account after a year. So let's get a little bit more stuff into here. Let's do this work also for Cassie. Let's figure out our equations that we have going on. So I'm going to do a little bit of erasing so we can see what our total equation for John is going to be. So for John, his account, J, that's going to be equal to the initial $100 that he puts in there. There's our initial amount, our y-intercept. Our growth factor we figured out is 1.06. The 1 indicates that we're always going to have that $100 accruing, and then the 0.06 is that growth rate. And then that is to the y. I'm going to say y because it's years. And now I can erase everything else that I have here. So that's John's equation. Now let's look at Cassie's equation. Cassie, C, She has $150 that she starts out with. She also has that same growth factor, 1.06, and she's raised to the y power. So looking at this information, we probably can figure out what is going to happen. For John, is he going to have as much money as Cassie after a year? Probably not. After 5 years? Still, probably not. And after 10 years? Nope, I doubt it. Mainly because he is starting out with the same initial value as Cassie, and then, or like a different initial value as Cassie, a lower initial value, and they still have that same growth factor. So that's not looking for his best interest as of right now. So let's figure out for the first year how much John has in his bank account. And we'll do the 5th year, and if I have enough room, we'll do the 10th year. And we'll compare these babies. So John, for the first year, we've already figured that out. We have 100 times 1.06 raised to the first power. 1.06 raised to the first power is just 1.06, so we end up with 100 times that, and we get $106 for John. Actually, I'll do this in orange so we can see it well. So John has $106. Cassie, on the other hand, she starts out with 150. So her growth factor is going to be affected by that. We have a growth factor of 1.06 raised to the first power, so it's just itself, times $150, and we get a value for Cassie, which I'm going to do in gray because we started out with gray, as $159. So she still has more money than him by $53. So the difference, I'm going to write the difference over here, is $53 between the two of them. Now John is going to be doing the same thing. He's leaving in his money in his savings account, which is a good thing. That means he's accruing interest over time. And if he keeps it in there for 5 years, he now has $133.82. I'm going to say $134. $134. So still, he's gaining some money, not a ton, but he's got $34 more than he had before. And Cassie, on the other hand, let's see how much she has. 1.06 raised to the 5th power times 150, and, oops. All right, I did the math properly this time, and we get $200.73. So I'm going to rewrite that as 201. So the difference for her, I'm going to say this is an equal sign, and the difference for between the two of them, $201 versus $134 is $67. So the gap is getting bigger, guys. Then I'm also seeing we need to figure out John for 10 years. So John for 10 years, we end up with $179. $179. And Cassie, let's see if I can do my math right. Cassie ends up with a monstrous $268 in some odd sense. So looking at this information, we now have a difference between the two of them, $268 versus, minus 179, $89 difference between the two of them. So in all reality, what does the initial value how does the initial value affect the growth? Well, if you have lower initial values equals less growth than higher initial values, even if we have the same growth factor. So they don't grow at the same amount because that initial value really affects it. So let's move on a little bit. Which account will have more money at the end of the first year, 5 years, and 10 years? So we have the situation where we have $500 invested at a 4% interest rate and $400 invested in an 8% interest rate. I'm just going to do a little bit of the math after I create the equations and just have it magically appear. So let's first create these equations that we need to worry about, and then I'll magically pop up the math. So we have that initial amount of $500. We have a 4% interest rate. So that's our growth rate. Our growth factor for that would be 1.04. So we have 1.04 raised to the y, or our years. For this other one, we have $400. times 1.08, because 8% interest would look like 1.08 as a growth factor, raised to the number of years. So now I'm going to magically do a little bit of math so we can look at this information really quickly. All right, so here's a little bit of math that has been done. I've been using that equation, or the two equations that I've put up there. If we look at their first year, we see a difference between the two that is fairly substantial, about $90 between the two of them. $88 is the difference, I believe, between the first year, between the $500 and the $400. So if you were just keeping your money in for a year, it's best if you did the $500 at 4% interest. You'd end up with $520 after 1 year, whereas if you did the $400, you'd only be gaining $32 in interest, and you'd be at $400 still. Now, in the fifth year, if we kept it in for 5 years, we'd end up having $608 in 33 cents for that $500 at 4% interest. But what I'm noticing here is this gain that you're getting over on the $400 at 8% interest. If you look at that, we have gone from an $88 gap in the previous one to a $21 gap. This lower account is starting to gain on it, and it's because of this huge discrepancy in our growth factors. If we look at the next one, in 10 years, if you were to keep that money in for 10 years, you just did $500 at 4% interest rate, you'd end up with $740, whereas if you did $400 at an 8% interest rate, you'd have $863. So that is already a difference of $123 in favor of the $400 lower dollar amount. So which is the better option? You decide. That's your job. So now we're moving on. I'd like you to start on investigation 3.3 if you need. Here is the focus question for you again. Please do A through C. You should be able to do the whole investigation, and then after that, work on your homework. Have a great time. Bye.